Hey everyone, welcome classmates. I'm your resident animated Erlenmeyer Flask, and let me tell you, I am absolutely bubbling with excitement to guide you through this high-yield MYP chemistry study session. Just think of this as your ultimate crash course, perfectly calibrated to get you totally prepped for those upcoming exams. Oh, and this explainer is brought to you by our friends at GivenTutor. You can totally find us on Facebook and Line. We designed this to make basic step MYP chemistry not just easy to understand, but literally impossible to forget. It's like we're just hanging out, prepping right in front of the classroom together. So grab your notebooks, clear off your desk, and let's ace this thing. All right, so let's just dive right in with the most fundamental question of all time. What is everything actually made of? Seriously, just take a second and look around your room right now. Your desk, your computer, the air you're breathing, even you. What are the tiny, invisible building blocks that construct all of this reality? Well, answering that question is basically the entire point of chemistry. And mastering it, it's going to completely unlock how you see the world.
Okay, here's our quick study syllabus for today's explainer. 1. Meet your building blocks. 2. The states of matter. 3. The chemistry of change. 4. Your MYP exam survival guide. And 5. Chemistry for your future. Lots to cover, so let's get moving.
Section 1. Meet your building blocks. To truly get chemistry, we kind of have to shrink ourselves way down to the microscopic level. Let's look at how our scientific models have actually evolved over time. Way back in 1803, an English chemist named John Dalton proposed that atoms were indivisible, solid spheres. Think of them like tiny, hard billiard balls that just couldn't be broken down any further. But, science is all about updating our models when we get new evidence. So today, we know the modern atom is way more complex. It's got this dense nucleus right in the center, made of protons and neutrons, and it's surrounded by this super fast-moving cloud of electrons. Understanding how these models change and develop is a really huge conceptual part of the MYP sciences framework. And here it is, the periodic table of elements. Basically, a menu of all the different flavors of atoms we've ever discovered. But okay, here's a totally mind-blowing fact you should definitely remember for your exams. An adult human being has about 10,000 million atoms in their body. I mean, that is a staggeringly massive number. But despite that crazy number, about 98% of those atoms are just three types: hydrogen, oxygen, and carbon. Just three basic building blocks, combining in all these complex patterns to create literally all of human life. Crazy, right? Now, before we move on, I've got a crucial life-saving memory trick for your exam. When we write out chemical symbols, always remember this rule. The second is small. What do I mean by that? Well, notice how a capital C and a lowercase o represents cobalt, right? That's a metal. But if you accidentally write capital C, capital O, you haven't written a metal at all. Nope, you've just written carbon monoxide, which is a deadly gas. So yeah, in chemistry, capitalization really matters. A simple slip of the pen can entirely change the chemical you're talking about. Next up, let's talk about how these substances mix together. Like when you're making sweet tea or sugar water, you're creating what we call a solution. The solute is the stuff that dissolves, like those solid sugar crystals. The solvent is the substance doing the dissolving, like the liquid water. And when the solute particles get pulled apart by the solvent and become all evenly and uniformly distributed, congratulations, you've just made a solution. Seriously, lock down these three vocabulary words because they are practically guaranteed to show up on your test. Moving right along to Section 2, the states of matter. Now that we know what particles are, let's see how they act when they get together in big crowds. So the absolute crucial point here is that the physical properties of a substance completely depend on how its particles are moving. In a solid, those particles are locked tight in place, just vibrating against each other, which gives the solid a fixed shape and fixed volume. Now in a liquid, the particles have a little more energy. They still have a fixed volume, but they can kind of slide past one another. That's what allows liquids to flow and take the exact shape of their container. And in a gas, oh man, the particles have so much energy they just fly rapidly and far apart, completely filling up whatever container you put them in. So how do we actually change from one state to another? Just remember the ABC of states. Step A, add heat. As you add heat to a solid, like say ice, you're pumping in energy. Step B, bonds break. All that extra energy allows the particles to overcome the forces holding them so tightly together. And step C, crazy movement. The particles start moving faster and way more freely, transforming from a solid into a liquid, and eventually, if you keep adding heat, boiling into a gas, which, by the way, is my personal favorite state as a flask. So remember, add heat, bonds break, crazy movement. And that brings us perfectly to Section 3, the chemistry of change. We've talked about states of matter, but what goes down when substances truly interact with each other? Okay, heads up, because this is a classic MYP exam trap. You absolutely must be able to tell the difference between a physical change and a chemical change. Here's a handy little memory trick for you. Physical is temporary, chemical is forever. Melting ice? That's a physical change. It's totally reversible. You can just freeze the water again, and no new substance was made. It's still just H2O. But a chemical change? That is forever. Chemical bonds are actually broken and formed, creating entirely new molecules. I mean, you can't unbake a cake, and you definitely can't unburn a piece of paper. Now, when a chemical change does occur, we call that a chemical reaction, and every single reaction has a before and an after. The reactants are the chemical substances you start off with. Just think of them like your raw ingredients. The products are the entirely new chemical substances you produce at the very end of the reaction. That's your finished, fully baked cake. Let's ground this in a real-world example, something like a roaring campfire. This is what we call a combustion reaction. Your reactants here are the wood and the oxygen in the air. When you add a spark, boom, a chemical reaction happens. The atoms literally rearrange themselves to form entirely new products. Ash, smoke, and a massive release of heat energy. The wood and oxygen you started with, they're gone, permanently transformed. Like I said, chemical is forever. All right, it's time to shift into pure survival mode. Section 4, the MYP Exam Survival Guide. Because honestly, knowing all the chemistry in the world isn't going to help if you don't know exactly how the test expects you to answer. So, the MYP uses these very specific command terms across all of their criteria. If you see the word state, do not, I repeat, do not write a whole paragraph. It literally just means provide a short answer or a single word. Overwriting is just going to waste your precious time. Now, if the question says explain, you can't just describe what happened. You have to give the detailed mechanisms and causes. You pretty much must use the word because. And then there's the big one, evaluate. If your teacher asks you to evaluate a scientific model, you have to list its strengths, list its limitations, and then give a final justified judgment at the end. Master these 3 terms, and you are going to snag maximum points on those assessments. Finally, let's zoom out to the big picture in Section 5, Chemistry for Your Future. Like, why are we even learning all this stuff in the first place? Well, this quote straight from your syllabus really hits the nail on the head. Mastering chemistry isn't just some hurdle to jump over so you can graduate. We study the properties of matter and chemical reactions because understanding these tiny building blocks allows us to engineer totally new materials. The whole MYP global context here is globalization and sustainability. By learning how to manipulate atoms, we can actually invent sustainable solutions to the massive, real-world problems facing our planet right now. Let me give you a totally mind-blowing example. Graphene. By carefully arranging carbon atoms into a flat sheet that is literally only one single atom thick, scientists have created an absolute supermaterial. I'm talking 10 times stronger than steel, yet insanely lightweight, and it conducts electricity and heat perfectly. The European Union is pouring millions of euros into graphene research right this second because it has the potential to completely revolutionize battery technology and create wildly efficient solar cells. This isn't just textbook stuff, this is chemistry shaping a sustainable future. And just like that, our study session comes to a close. You are now officially equipped with the knowledge of building blocks, the states of matter, and the golden rules of chemical reactions. Plus, you've got the secret codes to absolutely beat those MYP exams. I have been your faithful Erlenmeyer Flask tutor, proudly representing GivenTutor. But hey, before you pack up your books today, I really want to leave you with one final provocative question. With all these incredible atomic building blocks right at your fingertips, how will you use chemistry to change the world? Keep inquiring, keep experimenting, and good luck on those exams.